Oh yeah, we're going to do some Pythagoras theorem, but in 3D. And well, let's start off by saying Pythagoras doesn't really work in 3D as such, or at least not the way we use it. We're just going to use it in 2 dimensions, but we're going to use it in a way which means I can work out a length in a 3-dimensional space. It might sound complicated, but actually it's just the straightforward, ordinary Pythagoras we've done. We just do it twice in every question. That's it. Right, so it's not that much harder. It's just it can be visually a little bit hard to get your head around if you're not used to thinking in 3 dimensions. Okay, so here anyway, before we do that, here's just 2 straightforward questions from ordinary Pythagoras. These are right angle triangles. There's a little right angle at the corner, it tells you so. Let's relabel these sides. It wants you to find the length of x, which I've relabeled a little bit clearer. Pause the video, do your working out, do it to 1 decimal place please, and unpause when you are done. So the first one, the right angle is pointing at the long side, so I have not got the long side. I'm trying to find it. That means I need to add the other 2 together. So I square them, the other 2 sides, and add them. So that's 64 plus 100, which is 164. Now that's this side squared, and of course I don't want that side squared, so I square root. I do the square root of 164. Notice how I didn't use a calculator right up to that point. And in fact, I could still give my answer as a surd if I wanted to, which would be 2 root 41 centimeters. But because it said 1 decimal place, I'm going to do that, which is 12.8 centimeters to 1 dp. This time, that side is the long side, and I've got that, so I'm trying to find a short side. That means square, square, subtract square root. Square the 2 short sides, or 2 sides again, but we're going to subtract 1 from the other. Oh, 17 squared, is it 240 something? Oh, I can't remember. 289. Oh, dear me. So 289. Take away, no, I'm sure that's 196. 196, there we go. Because I need to make a short side, I need to subtract 1 from the other, which is 93. Now that is this, the short side squared, the x side squared. But I don't want that. I just want to find out the length of it on its own, not squared. So I square root it. And again, I could leave it in surd form, of which that's the simplest version, or I could put it as a decimal. And since I said 1 decimal place, let's do that. 9. That's 6 on there, isn't it? I'm trying to read my calculator. 9.6 centimeters. So either square, square, add or subtract, and square root. That's your basic Pythagoras kind of thing. Square the 2 sides, either add or subtract, depending if you're trying to find the long side, in which case you need to add, or a short side, subtract, and then square root at the end. But now we're going to start having a look at questions like this. So let's hear the guy in the video. I paid a really fantastic actor to do the voiceover for this. I ought to say thank you to MathsPad, although they haven't directly given me permission, although I do subscribe to the website to use their background here. You know, they did the graphics. I just did all the talking and drawing and stuff. So let's listen up for this world-famous actor to talk at us. So here we have a cuboid, and the cuboid's been labelled up with all the vertices, all the corners, called A through to G, but it's just a cuboid, it's a box. Okay, and the question it's asking us is how would we work out the length of DG? And that's what it means by DG, the distance from D to G going in a straight line. And they've marked it with a blue line there. Now, obviously on an exam paper, it would just be flat on the screen, just like that. For some, it's kind of hard to imagine, but this is rather cool because we can actually pull this around and have a little look at the cuboid from different angles. So there's the front, there's the side. We can clearly see the length we want to find there, or the back, or maybe look from above. So, we can get a really good idea of what this cuboid is. Now, in this case, this is actually a straightforward, although it's a 3D shape, we're actually only after a 2-dimensional thing. We're only after a line, a distance between 2 points. And actually, if I just show up this triangle, you can see because it's a cuboid, we've got a right-angled triangle. We've got the base, which is the same as that length on the cuboid. We've got the height of the triangle, which is the same as the upright on that cuboid. And then the diagonal is the hypotenuse of this one. I'll stop moving it around, probably make people a bit seasick. And I can also see that we have got, oh, if it actually lets me draw there. Come on, let me draw. Why won't you let me draw? I want to draw. Oh, I see, right, because it won't let me draw on the shape. That's annoying. But what I was trying to say was the long side here is the hypotenuse, is the long side on the triangle. Now, if you remember our Pythagoras, if we square one short side and we square the other short side and add them together, it will be the same as this long side squared. So the answer to this will be the same as the length of DG but squared. All right. And just to be clear, let's put DG in brackets. I don't know if you heard that, but Alexa's joining in. Great. So 4 squared plus 7 squared. Well, that's 16 plus 49, which is 65. Okay, right, so DG squared is 65. Absolutely nothing out of the ordinary here. This is just straightforward, ordinary Pythagoras. All I've done is just look to see what the lengths of the two sides are. Now, I would suggest that for today, when we're working in 3D, it's a really good idea to actually, use these surd form, write down stuff in square roots. I'll show you why later. Now, in this case, we're at the final answer. Now, at the last minute, we will use our calculator and get the final answer as a decimal, okay? So 8 point, let's do 2 decimal places, 8.06 centimeters, right? I didn't do anything out of the ordinary there. I just recognized the two sides of my triangle and went from there. Now, I suppose the one little leap I suppose I have done is that it asked me for the length of DG. It didn't say anything about a triangle here. But if I'm after a diagonal length, just like we did in the problem solving on the previous episode of this, lesson of this, I suppose, in the next season, we have Pythagoras in 4D. Now, we have, on the last episode, we were talking about problems and about forming that right angle triangle. So when you've got like a diagonal somewhere, form a right angle triangle. Just take the upright of that cuboid, take the length of it. There's a right angle in the corner. It's a right angle triangle. Okay, now as I've probably said already, there's no such thing as Pythagoras in 3D. All there is Pythagoras in 2D. It's a 3D shape, but the Pythagoras itself only works in 2 dimensions, really. So that's what we're doing here. We're just working on a flat surface. It just happens that flat surface is on the side of a cuboid. Isn't he a great guy? I think he's just awesome. Okay, so at that point, let's move on to a shape that is actually a length kind of in 3D. So now we do have a 3D shape, just as I said. And we're trying to find the... Well, I tell you what, he was so good last time. Let's hire that same actor to talk us through this question as well. Because he was good, wasn't he? Even if he's a little bit quiet, he is awesome. I wonder who he is. Now this time we've got a cuboid, and it's asking me to find another length, AG. So the length between the corner A and the corner G. And it's put a red line between to show you the length that it wants us to find. A straight line, not a wobbly line, not a line that sort of goes backwards and forwards. It is just a straightforward line. If I could get a ruler on that, I could measure it. Now, the thing is, this line is in, and once again, it's in a cuboid. It's in a 3D shape. Now, again, on the exam paper, you can't do this. But it's kind of cool that we can do this here. And it's on a cuboid, and it's literally from one corner to the top opposite corner. Now, Pythagoras, there is a kind of way you can work in 3D, but really, as I say, it only works in 2D, and it's easiest to work in it in 2D, particularly when we're explaining it. I can find this length, which is ostensibly in a 3D length, but actually, I can think of it as just 2D. So, if I think of this triangle here, this triangle that is inside my cuboid, I'll try not to turn it too fast, because otherwise it might get a bit confusing. But look, there's my triangle, my right angle triangle, and this red line that I want to find the length on is once again just the long side on a right angle triangle. If I knew the two short sides, happy days. Pythagoras. I can just do it. I can square one of those short sides, square the other one, add them, and then square root it. Add, square. No. I've even forgotten my own little thing. Square, square, add, square root. Straightforward. Now, the problem here is, of course, although I've got one side of my right angle triangle, I don't have the other side. I've only got one side of my triangle at the moment, which is a bit of a problem. What I need to do is find the length of that base of that right angle triangle. But let's look at what that is. If I just look straight down on my cuboid, it's just across the base, diagonally across the base of my cuboid, just straight from one corner across the bottom of my cuboid to the other. And look at the triangle. Let's highlight that other triangle. It's the long side on this triangle here, isn't it? Just straight across the base there, diagonally from one side to the other across the base. And look, we can find the length of that triangle. In fact, let's do that now. And this is what we do when we're working in Pythagoras in 3D. We generally just do Pythagoras twice. So ordinary two-dimensional Pythagoras, we just do it twice. Once to find this length, and then we use the answer as part of another triangle. So let's do the AC first of all. So AC, the length of AC across the diagonal, across the bottom of my triangle. That's fine. Cuboid, let's find that. Now, I've got my two sides, my 3 and my 7. Look, it makes a right angle in the corner. So I square one short side, I square the other, I add them together, and get the answer. So 3 squared is 9, 7 squared is 49. Add them together to get 58. Okay, so that's that length squared, isn't it? That's AC squared is 58. And so the length of AC is the square root of 58. Now, don't put it as a decimal because you are going to need this answer in a minute. That answer there, root 58, is the length between A and C. Now, obviously, as a decimal, it's about 7.6, but I want to keep full accuracy. And more to the point, I want to make my life and your life considerably easier by not having to deal with some decimal that I'm going to have to round. I'm going to leave it like this. It's, absurd form, isn't it? But I'm not asking you to simplify it. Just leave it like that. Okay, get the message that you want me to leave it? Yep, good. Right, so we know that length now, AC. Now, remember, the other triangle whose hypotenuse we want to find the length of, AG, the short side, or one of the short sides on this second triangle, this peach-coloured triangle here, that is this length. That is AC. That's why I found that length. So now I've got two triangles. I could even just quickly draw them again. My new triangle that I want to find has the length of 4 up the side, but this bottom length is, is it not going to let me draw it? That's really frustrating, isn't it? Let's put it on the inside. Is root 58. You can't really read that, but what I'm trying to get across is that triangle, the bottom length of that is 58. It was being a bit annoying, wouldn't let me do it. So now I can find AG. Now remember, AG, that length squared will be the same as one short side squared. The other short side squared added together. Now, 4 squared is 16. See, I'm not even using a calculator at the moment. This is so easy. What's the root of 58 squared? Now, you can use your calculator. You'll be amazed what the answer is. It's 58. Because I've square rooted it, but then squared it again. Yeah? So 16 plus 58 is 74. So that long side, AG squared, equals 74. And as with all Pythagoras questions, just square root it at the end. So square root of 74. And at this point, this is right at the end, so I think we will actually give a decimal answer, which is 8.60 or 8.6 to 1 decimal place. So here's the basics. You use Pythagoras once to find the length, from diagonally across the floor, and then use it again as part of the next triangle. Use that answer again as part of the next triangle to find the diagonal there. So you just do it twice. So square, square, add square root for the base length, and then use that length with square, square, add square root again to find the diagonal length. Confused? Give it a go, right? It's easier than I make. Yeah, talking about it takes longer than it does to do. So I interrupted him there, didn't I? I didn't realise he hadn't finished. He's such a great guy. So yeah, you use it once to find that diagonal across the bottom. He does waffle though, doesn't he? So you find that length there, and then you can use that again as part of the next triangle, which is why we leave it in this third form, just to reiterate that, because it's easier to work with. If you change that to a decimal there, you're never going to be as accurate. So just leave it like that, square root of 58, and use your calculator like that. Now, if you haven't got a calculator, get online and use one online. There's plenty of them around, very easy to find. But otherwise, obviously, you should have a calculator. Let's have another look at another one. So this is your chance to have a go. Now, this time, I'll just, before we sort of do the answer, I'll let you know it is a cube. That means all the sides are the same. All right, it is a cube. And you're trying to find the length of CE. Use it once to find the length across the base there. So you need to find that length first, AC. And then you're going to use that as part of an upright triangle, the ACE triangle. And you're going to try and find that long one there. Now you know that one's 10. You need to find out the length of that side there. And then you can find out the length of your hypotenuse, which is what that is. Okay? Right, so pause the video, unpause when you're done. Okay, you've unpaused. Now, it turns out that our active friend he's free again. So, well, not free, I had to pay, but he's available. So he's going to talk us through the answer for this one. So listen up. So here's another problem, another cube, and this time it is a cube. Every side is 10, because it says it's a cube. And it says over here, one side's 10, so all sides are 10. Work out the exact length of CE. Now, this is interesting because it says exact length, so actually we want to leave our answer as a surd. We don't even want a decimal in this case, although, to be honest, I'll show you the decimal answer as well. Now, once again, if you're in an exam, they give you this little kind of skeleton picture of a cube. They might highlight the length they want you to find, they might not. Now, it says CE, they've highlighted it in red. It's just a straight line distance between C and E. And of course, in the exam, you can't move it around to visualize it, but I can move it around a little bit just to show you what we're after. Is that diagonal length straight from the top corner to the opposite bottom corner. Now, where's the triangle I'm going to use with Pythagoras? I can use this upright, which is 10, but the base of my final triangle is not going to be 10, is it? Because it's from A to C. It needs to go diagonally across the floor there, like that. There's the top view. Which means I need to use Pythagoras first to find the hypotenuse of this triangle here, the blue triangle. Yeah. So let's do that first. So that's AC. So I need to find the length of AC. Now, if I square one side of that triangle and square the other short side, because AD is 10, DC is 10, because it's a cuboid, right? All the lengths are 10. So that's 100 plus 100, that's 200. But I don't want AC squared, I just want AC, which means I need to square root 200. And that is the length of AC, the root of 200. Okay, now I'm going to leave it like that. I'm not going to give my decimal answer, which is it's like 14 point something or other. I'm going to leave it like that. Now, obviously, I can use that as the base of my new upright triangle there, the one that sort of stood on its end. Now I know one side of that triangle. I'm going to find my final length now of CE. One side is 10. That's the upright side. But I want the base of that as well. Now that's the answer to the previous question, isn't it? Which is root 200. So I'm going to take that side and square it. So I've squared the upright, squared the bottom diagonal, add them together, because this is ordinary Pythagoras. Square, square, add, and then we'll square root in a minute. Now that's 100 plus 200. Look, because this is 200. If you square it and square root it, you just get 200. Check it on a calculator if you don't believe me. But that is 300. Okay, now CE, that's CE squared, the long side squared. But I want CE itself, so I have to square root. Square, square, add, square root. And that's 300. Okay, now at this point, I think we could simplify it. It's not complicated things with that. I'll tell you what the answer was. If you simplified that surd, you would get 10 root 3. I don't think I'm going to the surds now of that. If you need help with the simplifying of surds, then look it up. But let's imagine that it asked for a decimal answer. Well, if it asked for a decimal, that would be 17.3 centimeters. So this is the idea. There's no such thing really as 3D Pythagoras in our world. Generally, we just do Pythagoras twice, but flat. So in this case, it was once across the bottom, just like the last question, to get that diagonal. Then I use that answer as part of another triangle that's upright to get that length instead. Okay? Oh, what a guy. And there he goes. He's left the building with his wages. So let's try it again. Okay, I've got a few for you to try. And I'm going to just highlight the length I want you to show. Now, remember, this is a cube, so all the lengths are 4. And these are just like they would be in a test. We're going to do 3 questions, just like they would be, and you've got to do the working out. You might want to sketch them out, up to you. We're trying to find the length of AG, so that goes from A up to G. Pause the video, do the working out, and unpause when you are done. Now, if you need a little hint, remember, your final triangle will be made up of the length AC as the base, then the upright over here, which is 4 centimeters, will be the other side of the triangle. You need to find this length first, so I've just put a question mark on, and then you can find the final diagonal length. So pause and unpause when you're done. Okay, let's go. So firstly, let's find the length AC. Now remember, obviously, first of all, we have to find AC squared. So we'll take the 2 sides of AC. Now that bottom edge is 4 because they're all 4. So both short sides are 4. So we'll square one, square the other, and add. So 16 plus 16 equals 32. So that's AC squared. So that line squared. But I don't want AC squared, I just want AC. So I do the square root of 32. And I'm just going to leave it like that for now. I'm not even going to simplify that. It's just absolutely pointless. Leave it like that. So this line down in here, I can now say is root 32 centimeters. Now, if I then want to find the final answer, which I want, which is AG. Now, I have to find AG squared first of all, don't I? And I take one of its sides and square it. That's the upright. And then I take the other side, which is root 32, and I square that. Add them together, so square, square, add, and then we'll square root in a moment. And remember, 32, if you square root it and then square it again, you just get 32. So that is 48. So that's my side squared that I want. So to find the actual length, I need to square root. Don't forget, Pythagoras every time. Square, square, add or subtract, square root. And the square root of 48 is, now you could give it as a surd as 4 root 3, but as a decimal to 1 decimal place is 6.9 centimeters. So we used it once to find that diagonal across the base, and once to find the diagonal from one bottom corner to the top corner. Okay? All right, try another one. So the cuboid here with different lengths on the sides of the cuboid. Find the length AG, that's A to G. Here it is, I've put a red line on there. Pause the video, unpause when you're done. Okay, you are done. Right, now remember, again, if I want to find the length of that top line, the AG, sorry, I'm going to use a triangle that's upright on its end, just like that. Now that bottom edge, I don't know yet. I know the upright is 4. I need to find this one in here, AC. Again, it's funny how it's always AC. That's just coincidence. Right, one side of this triangle across the floor. Maybe do these in different colours then. So the triangle across the floor is 8 and 3. So square those 2 short sides and then add them. So 64 plus 9 is 73. And then, of course, we need to square root that to get the length AC. Now I'm not even going to simplify it, I'm just going to leave it like that. So a bit of a change of pen to a red. I'm now going to try and use this triangle that's upright here, stood on its end. Now it's got two lengths. Remember, AG is the thing I'm trying to find now. The upright is 4, and the one across the base there is root 73. Just use it like that. So square one of those, square the other one, add them. 16 plus 73. This is why we use these as square roots and we don't turn it into a decimal. It's so much easier and faster as well. 89 is the length I want, but squared, because that's how Pythagoras works. The last thing is always square root it. Square root of 89 is just, that is the third form. It doesn't simplify any further than that. But as a decimal, 9.4 centimeters. See how quick it is once you get used to it. Once you know kind of what you're doing, use it once to find that bottom diagonal, another time to find the diagonal from the bottom corner to the top corner. Really swift. Okay, one more then. So diagonal of BH, there's B, there's H. There's a little line between them. The pause sign is on, so pause the video, unpause when you're done. So, right, now this time it's not any different really, but the triangle I'm thinking of is just looks slightly a different way round to what we've been doing before, but it's still the same thing. So I've got my upright. Now I know that that upright is 2 centimeters because it's going to be the same as this end. I don't know the base yet, so let's change colour. Go to a blue. So I'm going to find the hypotenuse of that triangle that I've just sort of shaded in on the floor, which is DB. So let's square one side. So we've got a length of 5. This length over here is 3. The one on the floor there. 3 and 5. So take one of them, square it. Take the other one and square it, and then add. Square, square, add. Which is 34. Now, of course, that's my dB, but squared, so we need to square root it. And the square root of 34 is just square root. It doesn't simplify any further, and I don't want to simplify it any further. So this length across the bottom here is root 34, square root of 34. I've got my two sides. Now I can find that long side that I want between B and H. So BH. Now remember, when I first do this, it will be BH squared. I'm going to take one side, which is 2. That's that upright, and square it. I'm going to take the base of the red triangle there, which is root 34, and I'm going to square that. I don't know why I'm writing on a jaunty angle like this. 2 squared is 4. Root 34 squared is 34. Let's try and level this up a bit. It's a bit ridiculous. So 38. Right, so my BH squared is 38. Can you remember, you know, we've done the square, done the other square. That's ridiculous, Mr. Nice. Let's just do that again. Don't be silly. Come on. Do it properly. So we've squared one, we've squared the other. We add or subtract. Well, in this case, we're adding because we're trying to find the long side. And then the last job is always square root. So the length of BH is the root of 38. Which is 6.2 to 1 decimal place. Okay, right now I've set up some questions for you probably on Dr. Frost, unless you're not my student, then I haven't done. But I probably have done for those that know me. So otherwise, well done. I hope it helped. And go do some practice. That's the main thing. Lots and lots of practice. And see you next time. Bye-bye.